Org design and change management, rolling out autonomous coders safely. Introduction. Autonomous coding agents are software tools that can inspect a codebase, understand an issue, plan a change, edit files, run tests, and open a pull request for human review. Some can also operate on a schedule, respond to repository events, classify issues, update dependencies, or maintain documentation. That capability changes more than the developer workstation. It changes who performs software work, how work is assigned, how code is reviewed, what managers measure, and where accountability sits. The safest organizations do not begin by asking, how quickly can we let the agent write production code? They ask, which work is safe to delegate? What evidence must an agent provide? Who is accountable for the result? What permissions does the agent need? How can the organization stop or reverse its actions? How will developers learn the new workflow without feeling threatened? The evidence so far supports a cautious, context-dependent approach. A 2025 randomized study by the Model Evaluation and Threat Research Organization found that 16 experienced open-source developers took 19% longer, rather than less time, when using early 2025 artificial intelligence coding tools on familiar repositories. Other field experiments have reported productivity gains in different environments. The lesson is not that coding agents are ineffective. It is that tool capability, task type, developer experience, code-base quality, and organizational workflow all matter. The 2025 DevOps Research and Assessment Report reaches a similar organizational conclusion. Artificial intelligence acts as an amplifier. It strengthens organizations with clear workflows, reliable platforms, good testing, and strong feedback loops. It also magnifies weak processes, poor documentation, unstable priorities, and unclear ownership. This article presents a practical operating model for adopting coding agents safely through pilot squads, a center of excellence, and federated governance. What autonomous coding agents actually change? Traditional coding assistants provide suggestions while a developer writes code. More autonomous agents can perform a sequence of actions: read an issue or task description, inspect relevant files and documentation, create an implementation plan, modify multiple files, run tests, linters, and security checks, explain the changes, open or update a pull request, respond to review comments, repeat the cycle until the work meets defined conditions. For example, GitHub Copilot Cloud Agent can research a repository, make code changes, and create a pull request for review. Its automations can run on schedules or in response to issues and pull requests. GitHub also documents controls for limiting tools, reviewing agent sessions, disabling automations, and requiring human review before merging. This creates 4 organizational shifts, from writing code to directing and evaluating code, from individual tasks to task queues that agents can process continuously, from periodic maintenance to continuous maintenance, from implicit developer judgment to explicit policies, tests, instructions, and approval rules. Coding agents are most useful for organizations that already have source code and version control, a functioning pull request process, automated tests, clear ownership of services and files, reproducible development environments, a willingness to measure outcomes rather than rely on enthusiasm. They are less suitable as a first step for organizations with no reliable testing, undocumented systems, unclear ownership, or a culture that treats every new tool as a mandate. The core design principle: govern the workflow, not just the model. A coding agent is only one part of a larger system. Safe adoption requires controls around identity: which person or service account initiated the task; authority: what may the agent read, change, or execute; evidence: what tests, scans, and explanations must accompany the change; review: who must approve it; deployment: how gradually can the change reach users; observability: can administrators reconstruct what happened; recovery: can the change, agent, or feature be stopped quickly? The National Institute of Standards and Technology recommends considering trustworthiness throughout the artificial intelligence lifecycle, including design, development, deployment, use, testing, and evaluation. For coding agents, this means risk management cannot be postponed until after the first incident. A useful internal rule is, an agent may propose, prepare, test, and explain a change. A human organization remains accountable for deciding what enters production. That rule can become more flexible at higher maturity, but only when the organization has strong evidence, bounded permissions, reliable rollback, and clear stop conditions. 3 organizational patterns that work. Pilot squads. A pilot squad is a small team that uses coding agents on real work for a defined period. It is not a demonstration project using artificial tasks. The squad should work on a real repository, real issues, and real delivery constraints. A strong pilot squad includes 4 to-be developers with different levels of experience, an engineering manager, a product or business representative, a security or quality representative, someone familiar with deployment and operations, at least one person who is skeptical or cautious about the technology. GitHub recommends that pilots include real work, a mixture of skill levels, and a range of teams and workflows. It also recommends defining success criteria, setting a budget, and running a pilot long enough to gather meaningful data. For usage-based agent features, GitHub suggests planning for at least 1 full billing cycle, commonly 4 to 6 weeks. Best use cases, pilot squads work especially well for writing unit and integration tests, documentation updates, small bug fixes, refactoring with strong test coverage, dependency updates, log, monitoring, and configuration improvements, drafting pull request descriptions, converting repetitive issue work into standard workflows. What the pilot should not do, avoid beginning with authentication and authorization changes, payment logic, irreversible database migrations, safety-critical software, large cross-service redesigns, production access for an unrestricted agent, individual employee productivity scoring, pilot exit criteria. Before the pilot begins, define a written go, pause, and no-go decision. Go if quality remains stable or improves. Security findings do not increase materially. Reviewers can understand the changes. Developers report that the workflow is useful. Agent costs remain within the approved ceiling. The team can stop or reverse agent activity. Pause if pull request review time increases sharply. The agent repeatedly makes the same class of error. Bot-generated work overwhelms maintainers. Developers feel pressured to use the tool without training. The organization cannot explain what the agent changed. No-go if the agent bypasses required approvals. Sensitive data is exposed. Critical vulnerabilities are introduced. The agent cannot be reliably contained. The business case depends only on optimistic opinions rather than measured outcomes. Center of Excellence model. A center of excellence provides shared standards, training, tooling, evaluation, and support. It should not become a central team that approves every experiment or writes every agent workflow. Microsoft's current agent adoption guidance describes an effective center of excellence as a small, cross-functional group that provides enablement, standards, governance, and scale. It recommends a progression from a hands-on centralized team at early maturity toward a lighter ecosystem and community role as local teams become capable. A coding agent center of excellence might include an engineering productivity lead, a security engineer, a platform or developer experience engineer, a software quality representative, a change management or learning specialist, a product or business representative, a legal, privacy, or compliance advisor when necessary. Responsibilities of the Center of Excellence. The Center of Excellence should own approved use cases and prohibited use cases, risk classification for agent tasks, standard repository instructions, pull request and branch protection policies, testing and scanning requirements, agent identity and access patterns, training materials, evaluation datasets and test repositories, cost controls, audit and incident procedures, a library of reusable prompts, templates, and workflows, a community of practice and champion network. It should not own every local implementation decision. Its purpose is to make safe behavior easy, repeatable, and visible. Federated governance. Federated governance combines a central baseline with local team ownership. The central organization sets minimum requirements. No direct merge to protected branches. Required pull requests. Required tests and security checks. Human or code owner approval for sensitive areas. Least privilege access. logging, and attribution. Defined rollback procedures. Approved models, tools, and data handling rules. Local teams decide which tasks are worth automating, how repository instructions should be written, which domain-specific tests are required, which engineers serve as local champions, how the tool fits into the team's planning and review process. Microsoft describes a similar separation between platform responsibilities and workload responsibilities. The platform team provides the secure foundation and governance, while workload teams own domain-specific value and lifecycle decisions. This model is usually the best long-term structure for a large organization because it avoids two common failures. Centralized bottleneck. Every experiment waits for one committee. Uncontrolled sprawl. Every team invents its own tools, permissions, review rules, and data practices. Recommended progression. For most organizations, the strongest sequences begin with 1 or 2 pilot squads. Form a small center of excellence from people involved in those pilots. Move to federated governance as more teams adopt the workflow. Keep central control over identity, security, evaluation, and production access. Keep local control over domain use cases and day-to-day practices. Change management. Building trust without creating backlash. Start with a trust contract. Developer backlash often comes from uncertainty rather than opposition to the technology. People want to know whether the tool will be used to help them, monitor them, replace them, or judge them. Google's research on developer trust recommends 5 practical strategies. Publish a clear, acceptable use policy. Strengthen code review and automated testing. Give developers opportunities to build familiarity. Explain how developer roles may evolve beyond repetitive work. A practical trust contract should state: the purpose, improve delivery quality, reduce repetitive work, or increase learning capacity. What is allowed? Examples of safe and useful tasks. What is prohibited? Sensitive data handling, unrestricted production access, and unreviewed merges. Who is accountable? The person and team responsible for the change remain accountable even when an agent wrote it. How telemetry is used. Adoption data should improve enablement, not become a simplistic employee ranking system. What will not happen? No hidden rollout, no automatic replacement promise, and no individual quota for agent usage. How people can disagree. A visible channel for reporting problems or requesting a pause. Train people by responsibility. Training should not be one generic 2-hour demonstration. It should be role-based. For non-coders and product teams, teach people how to write clear issues, describe desired behavior in plain language, define acceptance criteria, identify sensitive or high-risk requirements, review a demonstration or test result, ask an agent to explain a change without needing to read every line of code. This makes coding agents useful to people who understand the business problem but do not write software. For developers, teach how to give an agent useful context, how to ask for a plan before implementation, how to inspect a diff, how to verify tests rather than trust the agent's summary, how to check dependencies, secrets, permissions, and error handling, how to recognize prompt injection and untrusted repository content, how to stop an agent that is looping or making unrelated changes. Google's research found that trust increases when developers gain exposure to the tool, especially in languages and environments they already understand. For reviewers, teach reviewers to focus on whether the change solves the stated problem, whether the tests cover the important behavior, whether the change introduces security or privacy risks, whether the design fits the existing architecture, whether the agent changed more than necessary, whether the pull request is small enough to review confidently. For engineering managers, teach managers to measure delivery quality, review load, rework, lead time, developer confidence, incident rates, maintenance backlog, customer outcomes. Do not use lines of code as a primary productivity target. GitHub describes lines of code metrics as directional and recommends considering adoption, acceptance, pull request lifecycle measures, and qualitative feedback together. For security and operations teams, teach agent identity and access control, tool allow lists, prompt injection risks, secrets management, audit logs, kill switches, rollback, and incident response. Use champions without creating unpaid support roles. A champion is a trusted team member who experiments with the tool, shares practical guidance, helps colleagues, and brings feedback to the center of excellence. Microsoft's adoption guidance recommends giving champions training, recognition, access to experts, and a voice in shaping standards. Champions should not simply become an unpaid help desk. Their time and responsibilities should be agreed with managers. A useful champion program includes monthly community meetings, a shared discussion channel, office hours, short demonstrations using real work, a library of successful and unsuccessful examples, recognition for teaching and feedback, a clear escalation path to security and platform teams. Communicate in stages. A practical communication sequence is: before the pilot, explain the problem being addressed. State what is in scope and out of scope. Publish the trust contract. Explain how success will be measured. Invite skeptical questions. During the pilot, share weekly progress. Publish failures as well as wins. Report review load, quality findings, cost, and developer sentiment. Adjust the workflow based on evidence. After the pilot, publish the decision. Expand, pause, or stop. Explain what changed in the process. Share reusable practices. State what remains human-controlled. Give developers a clear next opportunity to participate. A useful message is: coding agents can draft and test changes, but people remain responsible for intent, review, risk, and production outcomes. We will expand autonomy only when evidence shows that quality, security, and developer experience remain healthy. A practical maturity model for coding agents. Maturity should be based on evidence and control, not on the number of licenses purchased. For the full table, please open this article on easycoding.tools. Stage 5 should be treated as an exception, not the assumed destination. Google's Site Reliability Engineering Guidance describes progressive autonomy. Systems move from assisted analysis to human-approved action, then to bounded autonomous action only after stronger evidence and controls are in place. It emphasizes least privilege, interruptibility, dry run support, risk evaluation, and continuous evaluation. Promotion criteria between stages. A team should move to the next stage only when it can demonstrate stable or improving defect rates, no unacceptable increase in security findings, a manageable review burden, clear agent attribution, reliable test and deployment signals, a reversed rollback, developers who understand and trust the workflow, a documented list of tasks the agent must not perform. Continuous maintenance bots deserve special caution. Maintenance work appears low risk, but it can create large volumes of changes. Examples include dependency upgrades, documentation synchronization, test repair, static analysis remediation, configuration updates, issue labeling and triage, removal of obsolete code. Existing tools such as Dependabot demonstrate a useful pattern. Automated systems raise pull requests, but tests and acceptance processes should still run before merging. Automatic merging should be limited to clearly defined, low-risk cases with required status checks. For language model-based maintenance bots, add a maximum number of open bot pull requests, a maximum number of retries per task, a maximum daily budget, automatic closure of stale or duplicate work, a required human owner, a rule that the bot must not modify its own permissions or workflow definitions. Risk register for autonomous coding adoption. A risk register should be created before the pilot and reviewed during every expansion decision. For the full table, please open this article on easycoding.tools. GitHub's current documentation identifies several of these risks directly, including unvalidated code, sensitive information access, prompt injection, loss of administrative visibility, and automations operating without a person initiating each task. Its documented mitigations include branch restrictions, required human review, workflow approval, session logs, and limited tools. The Open Worldwide Application Security Project's 2026 guidance on agentic security and governance also reflects the need for threat modeling and governance specifically designed for systems that can act, not merely generate text. Rollback playbooks. A rollback playbook should be written in plain language and rehearsed before an autonomous agent is allowed to create production-bound changes. Playbook 1. Contain the agent. Use this when the agent behaves unexpectedly, leaks information, creates excessive work, or violates its task boundary. Disable the affected agent, automation, or model policy. Stop scheduled and event-triggered runs. Revoke or suspend the agent's credentials. Prevent new pull requests from being created. Preserve session logs, prompts, diffs, and audit records. Identify all repositories and branches touched by the agent. Notify affected maintainers and security personnel. Open an incident review. Do not re-enable the agent until the failure mode and control gap are understood. GitHub provides controls for disabling automations and reviewing agent sessions. It also records agent-authored commits and audit events, which supports this type of containment process. Playbook 2. Revert an unsafe code change. Declare the incident and identify the last known good version. Stop further rollout. Revert the pull request or deploy the previous known good release. Use a canary or limited deployment if the rollback itself is risky. Verify service level indicators, error rates, security signals, and customer impact. Preserve the original change for investigation. Identify whether the problem came from the agent, the task description, missing tests, review failure, or deployment process. Add a regression test or guardrail before reopening the task. GitHub's pull request workflow can create a new pull request that reverses a merged pull request. For production systems, canary deployment is a complementary control because it limits the number of users exposed before a change is promoted further. Playbook 3. Stop a risky deployment. For production-bound changes, use stage deployment rather than an immediate global release. Define automatic halt conditions before deployment. Monitor errors, latency, availability, security alerts, and business outcomes. Maintain an emergency stop mechanism. Roll back to a previously verified release when thresholds are exceeded. The Cybersecurity and Infrastructure Security Agency recommends canary deployments, controlled rollout, monitoring during expansion, and an emergency stop mechanism. Google's Site Reliability Engineering Guidance similarly recommends canarying as a way to expose only a small portion of traffic while validating a change. Playbook 4. Roll back the adoption stage. Sometimes the code is safe, but the operating model is not ready. If review burden, developer frustration, or maintenance noise becomes excessive, pause expansion. Return teams to the previous maturity stage. Disable the highest autonomy features first. Keep low-risk assisted coding available if it remains useful. Fix documentation, tests, permissions, or training. Rerun the pilot with narrower task boundaries. A rollback is not a failure of the program. It is a sign that the organization is using controlled experimentation rather than treating adoption as irreversible. A 90-day rollout plan, days 1 through 10, establish the baseline. Create a one-page charter containing business problem, pilot repository or service, tasks included, tasks excluded, team members, agent permissions, required reviews, required tests and scans, cost ceiling, success metrics, stop conditions, rollback owner. Measure the baseline before enabling the agent. Pull request cycle time, review time, rework, defect rate, security findings, deployment frequency, change failure rate, developer confidence, maintenance backlog. Days 11 through 45, run the pilot. Use real work. Hold a short weekly review covering what the agent did, what humans had to correct. Which tasks were suitable? Which tasks were surprisingly difficult? Whether review effort increased. Whether the team understands the changes. Whether costs match expectations. Add one question to the team retrospective. Where did the coding agent reduce effort this week? And where did it create more work? GitHub recommends combining usage data with surveys, retrospectives, support trends, and other qualitative feedback rather than relying on a single adoption number. Days 46 through 75. Form the operating model. Use pilot participants to create the initial center of excellence. Publish acceptable use policy, risk classification guide, repository instruction template, pull request checklist, agent access standard, security review checklist, training path, rollback playbook, approved metrics, champion program. Days 76 through 90. Expand carefully. Add teams in waves, not all at once. For each wave, confirm the repository has required tests and ownership. Confirm branch protection and code owner rules. Train the team. Assign a champion. Define the permitted task categories. Set a budget and review capacity. Measure quality and developer experience. Decide whether to continue, pause, or narrow the scope. The first next step. The best first action is not purchasing more licenses. It is scheduling a 60-minute autonomy design workshop with one engineering team, one product representative, one security or quality representative, and one platform representative. During the workshop, choose one repository, one low-risk task category, one human approval rule, one measurable outcome, one stop condition, one rollback owner. A suitable first task might be, every week, inspect dependency alerts and open a pull request for approved patch level updates. Do not change application logic, deployment configuration, authentication, or workflow permissions. Run the full test suite and security checks. Stop after 3 failed attempts or when 5 open maintenance pull requests exist. That small workflow teaches the organization how to define scope, permissions, evidence, review, and recovery. Those lessons are more valuable than a flashy demonstration. Conclusion: the safe adoption of autonomous coding agents is primarily an organizational design problem. The strongest model is usually pilot squads to learn on real work, a center of excellence to provide common standards, training, evaluations, and guardrails, federated governance to let local teams move quickly within a safe central boundary, a maturity path that progresses from assisted coding to agent-created pull requests, and only then to continuous maintenance bots, a risk register and rollback playbook that are written before autonomy expands. A change management program built around trust, transparency, voluntary learning, role clarity, and measurable outcomes. The goal is not to remove people from software development. The goal is to move human attention toward architecture, product judgment, security, reliability, user experience, and the design of better systems. Autonomy should be earned by evidence. When an organization can explain what its agents are allowed to do, prove that their work is checked, and stop them without drama, coding agents become a force multiplier rather than a source of chaos. Selected sources. Source 1, DevOps Research and Assessment, State of AI-Assisted Software Development, 2025. Source 2, Model Evaluation and Threat Research, Measuring the Impact of Early 2025 Artificial Intelligence on Experienced Open Source Developer Productivity. Source 3, DevOps Research and Assessment, Fostering Developers' Trust in Generative Artificial Intelligence. Source 4, Microsoft Learn, Agentic Artificial Intelligence Maturity Model, Organization and Culture. Source 5, Microsoft Learn, Organizational Readiness for Artificial Intelligence Agents. Source 6, GitHub Docs, Piloting a New Copilot Feature or Model. Source 7, GitHub Docs, Maintaining Codebase Standards in a GitHub Copilot Rollout. Source 8, GitHub Docs, Risks and Mitigations for GitHub Copilot Cloud Agent. Source 9, Google Site Reliability Engineering, Canarying Releases. Source 10, Cybersecurity and Infrastructure Security Agency, Safe Software Deployment. Source 11, Open Worldwide Application Security Project, State of Agentic Artificial Intelligence Security and Governance. Source 12, GitHub Docs, Creating Automations with Copilot Cloud Agent. All links to sources are available in the text version of this article. You can find the full article at easycoding.tools/blog. Thanks for listening. For more practical AI coding guides, tool comparisons, and resources for builders, visit easycoding.tools. And if it's easier to remember, just go to aibuilds.it